Hi, hello everyone. Sorry for keep you waiting. And I just initiate a broadcast, my screencast on our MS Teams. I just open our MS Teams. So if you like to see clearly the codes, I think the resolution over here will be a little bit harmful for your eyes. You can connect to MS Teams and log into your MS Teams and see the video, the live broadcasting. And if you would like to see the screen, you can move on and move closer to the screen. Okay. Uh huh. Camila, is it okay for you? You have an excellent sight, view sight. All right. It's good that we just get rid of the noise construction all the time. All right, let's go back to the class. Okay. Last time we are doing the falling mechanism, and sorry. Okay, I think we just have the final step to implement for our falling. So let's take a look at the falling part. It will be on page number 36. Okay, so falling with gravity. In our previous design, there isn't any effect of gravity. That is because we just every time we override zero to the y component of our velocity. Every time the physics engine is trying to accelerate the y direction speed, it just accelerates for one step only, and after that, our code will recover the y component back to zero, so it's impossible for our last code mechanism to cast any acceleration, I mean gravity, on this girl. So in order to solve the problem, we just need these three lines of code. Okay, let's take a look at these codes. So the line number 43, it just declare a new velocity, which is vector 3, and we just calculate our target velocity. It's a vector. So we just multiply the velocity. The velocity is a pure scalar. It's a float number. We just multiply this float number to a moving vector. The moving vector should be a vector 3. So the result will also be a vector 3. We store the value, we store the vector into new velocity. But since we want to copy the current y component of the speed, we're going to assign the y component of new velocity as rigid body velocity dot y. This is just copying the y component of our rigid body, the y velocity of our rigid body, and store the value to the new velocity. Okay, so that means we just preserve the current y component velocity of our rigid body, and without doing this, the y component will be overridden as zero. So now we should solve the problem. Oh, wait. We have to write back the new velocity to the rigid body velocity. Even we write back the new velocity to velocity of rigid body, the effect will be taken in next fixed update. Next fixed update. I should have elaborate what is the fixed update before. So just like we said before, the physics engine is running in another thread, and the other thread will be active only in another frequency. Everything related to rigid body is working in fixed update. So even right now, we are overwriting the velocity of rigid body in update. The actual effect will be taken when next time the fixed update is executed. So that's it. And let's try it again. Let's try it again. All right. With the help of the three lines of code, now our character should be able to fall in like this. All right, so I think this is a pretty simple modification to the codes. I think we can take about 5 minutes to implement the code, okay? Just these 3 lines of code, and it works like a charm. Okay, I think we have so many accounts in NTUT, you know that for the exchange students, I think we have three different accounts in NTUT. One is for Gmail, and the other one is for login to the MS Teams. So if you want to log into MS Teams, would you please ask for the other student that is sitting over here? Okay. Mhm. Ask your classmate how to use the correct account to log into the MS Teams. Okay, when you finish the following part of the codes, I need your help to check whether your character will be able to walking on a slope like this. So just like we can add a slope in the scene. This is a simple cube with some rotation angles. So after we put a cube like this, this would be pretend to be a slope in your level. So we can, by walking, we can climb onto the slope and try to go down to the slope to the other direction. Of course, you may find that the speed when when you climbing the slope and you go down the slope, the speed they are different. So that is because the friction forces that cast onto the character. So later we are going to modify the friction settings by the physics material next section. Okay. But before that, I need your help to try to walk onto the slope, like what I'm doing right now. Okay, so I think everybody should be able to finish the folding design. Okay, let's see what's going on the screen. Let's focus at the foot of this character. And wait. I didn't touch anything. I didn't touch my keyboard. I didn't swing my mouse. But obviously, she's falling. She's sliding down on the slope. Can you see that? I did nothing. But she's sliding down. What happened? What happened? Okay, so we should when we are studying in junior high school, we should be able to understand what is the friction process on the slope. There are two kinds of friction: static friction and dynamic friction. Luckily, we can set these values in Unity 3D. The physics engine will simulate the friction effect for us. We don't need to take care of the equation. Ooh, that's good. So how to set the friction settings in Unity? That is really simple. So let's go back to the project browser, and we're going to add some friction settings. Right click at the blank part, and we can select create and select the physics material. Where is this? Where is it? Physics material. Oh, it's over here. Physics material. And you will get a new physics material. So let's give it a name. Would be like no friction. No friction. Okay, so what is no friction meaning? No friction means it works like an ice or a polished ground, and when you are trying to stand over it, you are typically um, very hard to keep your balance because every time you try to step your steps further and you get inverse the inverse the friction force. So sorry, remember you are casting some force onto the surface. It's not possible, so you will be sliding. So click the no friction material and see the inspector over here. Whoa, we have two friction settings to set over here. One is the dynamic friction, the other is the static friction. Okay, let's set both of these friction settings to 0. The dynamic friction means your friction force coefficient, which will be casted when you are walking, when you are moving, when you are dynamically having some locomotion. So if this is the situation, your friction force will dependent to the dynamic friction efficient. Let's set the friction efficient to 0. Yeah, no friction. Right. So what is static friction? The static friction means the efficient you have your friction force be casted, and when you are idle, when you are having a 0 of speed, when you are standing still on this surface, and if this is the case, you'll have your coefficient equal to static friction. If both of the friction efficiencies over here are set to 0, that means by all means under every possible situation you will get no friction. Okay, and let's see below. There is a friction combined policy over here. Right now the default is average. So let's change the setting to minimum. That means if two services are close together and we have to decide the coefficient, what is the final merged coefficient? So if we select the minimum as the policy, and it will select the minimum coefficient from the two contacting services. Since I have the lowest the number of 0, I will dominate the calculation. I will dominate the coefficient. Okay. So for the bounce, we're not going to set the bounce part. So just keep the bounce part as default value. Okay. So right now, let's put the no friction material onto the collider of the slope. Select the slope. We see the collider over here, and the collider owns the material, which is a physical material. Let's put the no friction onto it. Boom. So right now the slope is very, very smooth, and I just sliding from the top. But Mr. Fu, I'm not going to make myself sliding on the slope. What should I do? What should I modify the efficient? Okay, we know that zero friction means the surface is very smooth. On the other hand, if you want to make the surface uh, rough enough to keep everything unchanged on the surfaces, then you can set the friction efficient to 1. Sorry, coefficient. So let's set the coefficient to 1. And this time, let's try to climb onto the slope. Oh, sorry, that's the minimum. I have to set the policy to maximum. The friction combined policy should be maximum. So, oops. Oh, the friction is too large, so that I can't climb onto the slope. Well, so let's try to change the coefficient to 0.5. Still start lighting. What on earth? Okay, if you can climb onto the surfaces, can climb onto the slope, you need to lower down the angle. Otherwise, the push algorithm will push you only to the horizontal direction. So let's just uh, rotate a little bit slide for the slope. Okay, actually, we're not going to modify the ground slope right now. We just keep it as the default settings. Because we'll have a wall collider later, and we have to take consider both the wall and the ground later. So right now, I'm just showing you that when you're standing on the slope, probably you are going to be sliding down because the friction problem. But we are going to deal with the friction problem later. Okay, just be aware there is such kind of a problem, and later we're going to fix it. All right, so let's go back to the section over here. We just finished the folding part. We just finished the folding design. Great. So let's now move on to the next section, which is jumping. Okay, before that, let's introduce what is the jumping mechanism that we are going to design. In order to jump, we need to apply a vertical thrust on the player. So what is thrust? A thrust means a very, very sharp, a very change of momentum that is applied in a very short period. This kind of momentum change is called thrust. That's a definition from your physics class. And if we apply a force onto a mass, I think you should be a little bit familiar with the equation over here. This is the Newton's second law, right? Okay. No, that's fine if you are not so familiar with it. And we're not going to implement the equation over here because our physics engine will deal with the equation for us. Ah, great. So that means when we want to jump into the air, we have to apply a sudden force in a very short period. The sudden force will last for only one frame. And after the frame, we are going to turn off the force. So that is the idea behind. Since we're not calculating the momentum, do you know momentum? Momentum is a unit to measure the status of movement in physics world. And we're not going to write any equation. Just remember that we're going to apply some speed change in one frame in order to let the character to jump. And after that frame, we're going to turn off the acceleration force. So everything recover back to an original cases. So thrust. So how to organize a code structure to apply some force or velocity change in a sudden. That is very simple. So here we add a flag again. Did I introduce the idea of flag before? Flag, F-L-A-G, flag. So you see that for some flag, I will start the prefix as is. I just write a flag called trigger enter before, right? I sometimes use a boolean to save the status of some working informations in my code. So if something happens, I will let this kind of boolean values to be true. Otherwise, the Boolean value may be set as false. So by reading this kind of Boolean value, I know so many information. I know what's happening in my code, right? So I think last time I just write the trigger enter. Actually, the trigger enter is called flag in the engineering world. Flag. Okay, so why these kind of Boolean variable are called flag? Because if you know how to use flags to communicate with other peoples, you just have simple limited poses to act. You can just raise the flag or just put down the flag. You just have these two kinds of poses. So just like somebody is trying to deliver some information with me, okay, so is the character jumping? So he will raise the flag. Yeah, this character is jumping. So later I'm going to wander to check is the character on the ground, and somebody may lower down the flag to indicate that the character is not on the ground. So I need somebody to pass me some information, and that information should be very simple for me to simple to observe and to judge. And the simple is the data type is Boolean. So for engineering's world, we always call this kind of Boolean a flag. So let's add a flag to save the status of the character. So this kind, I'm going to add a flag, which is a type of boolean, and I'm going to name this value is thrust. So right now, the is thrust will be shown whether should I cast a thrust onto this character or not. The default value is false. That means that I don't have to cast any thrust onto the character right now. But some days later, if I see that the is thrust is set to true, oh, the is thrust is set to true. Okay, I'm going to apply some forces on you. So that will make the code work like a jumping mechanism. All right, so let's add a E stress over here. So later on in the line number 48, this is where we are going to modify the y velocity. So last time we just copied the rigid body velocity y into the new velocity y. And after that, we should distinguish whether the strut is true or not. If the strut is set to true, bingo, I have to cast some force onto this character in order to make it jump. So if the strut is true, I'm going to return 1 for the expression over here. Otherwise, if the strut is false, I'm going to return 0 as the expression value for the expression over here. So after I got the return value, I'm going to multiply the return value to jump thrust. So this works like a toggle. If the thrust is true, the overall value of this expression will be jump thrust equal to jump thrust, which is a scalar, and I set the default value for jump thrust to 3. Otherwise, if its thrust is false, then this term will not be a non-zero value. The whole expression will be equal to 0. Smart and simple, right? And later we're going to let the other controller, the input manager, to send some message about our key button. So if I'm going to bind the enter key as the jump key, that means some later times when I hitting the enter key, and the code will receive some signal and something will be triggered, and then I can write the true or false value into the is thrust. So this is the subscriber method. I made a subscriber method called jump, and it was receive some value to indicate whether the jump button is pressed or not, and I just copy the value into is thrust. Okay, simple. And let's take about 5 minutes to finish the code, and after that you'll be able to see there is a little checkbox over here. Every time you check the box, you will see the character is jumping for once. Oh, sorry, I just missed the one red box over here. The line number 6 is added into the code but did not get properly annotated. So I just added a new red annotation box over here. So we have to add the jump thrust value over here. Okay, please be noted that I just missed the red annotation box. Oh, I just found another part. I didn't properly added the annotation. It's over here. We have to turn off the E thrust every time we finish the calculation of new speed. So the line number 50 should be surrounded by a annotation, but I just missed it. Okay, oh, I'm going to upload the slides of chapter number 6 again. Oh, Okay, I just update the chapter 6 PowerPoint slides on our iStudy system, and you may able to download it. Okay, now it may work like what you see on the screen. Every time I click the button, sorry, the checkbox over here, I will get uh, a sudden force. Actually, it's a sudden increasing in speed. An increase in speed means the changing of momentum, which coincidence with the idea of thrust. Okay, so how about if I suddenly click for twice? Let's have an experiment. Da 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 da. Oh no, I'm flying like a rocket. You see that? Now I can fly to the moon. Oh no. Oh, maybe you can make this again. But I mean, with some creative thought, you can maybe make this mechanism of the game. But this is what not what I expected the girl to work like it when she's jumping. This is not correct. So how to fix it? Mhm. So in order to fix a problem, you can use the finite state machine, right? What you have learned before the midterm project. So if you apply a finite state machine design pattern onto the character, and whenever she's right now in jumping state, you uh you can make the signal, the jumping signal. Okay, low power. Okay. you can you can temporarily ignore the jumping operation, ignore the jumping signal which deliver from the input manager. So finance state machine will greatly help your character to get avoid of more function operation like this. Okay. Otherwise, you are going to write so many codes to temporarily mute the jumping signal. All right, so I think we can have a tea break. Let's have a 10 minutes tea break. And later we are going to use the jump key on your keyboard to make the character jump. All right, let me go to recharge my battery. Okay. Okay, one, 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 two, one, two, one, two. Okay, welcome back. So, we just finished the thrust design, and now we are going to bind the jump subscriber method, this subscriber method, onto the event center. But before that, we have to make a little tweak about our input manager. So let me show the code to everyone. Okay, so this is the new version of our input manager. So um, in order to introduce a new event, we declare a Unity event over here, and this Unity event is called the event jump. So later the subscriber method will be hooked onto the event over here. So the event will pass a Boolean flag to the subscriber method. So we are going to use the generic type of bool set at here. Okay, so we also declare an abstract method which is named as calculate jump. So we are going to let the children of this abstract class to implement the solid body code, the concrete body code of how to calculate the jump signal. And yeah, you should know that this is the template design pattern, right? So if you forget about the design pattern over here, okay, never mind. This design pattern is called the template pattern. For template pattern, you'll be able to let the children to describe to implement the solid method of each of the tasks over here. Did you see that? This is the father class. This is the parent class. This is the abstract class of input manager. So it lets its children to decide the real body of these three abstract methods, which are calculate D-pad access and calculate jump and post-processing D-pad access. So the real task will be implemented in the children classes. But there is a duty for the parent class, that is to arrange the order of task or some other things related to the procedure of the overall process. So we see that from line number 15 to line number 16, we arrange the order of the task should be like this. So we call the calculate D-pad first, and call the calculate jump the second, and call the post-process D-pad access the third. So the parent only limits is just regulate the order of the tasks, but the real task will be dependent on the children's implementation. This is template design pattern. Okay, great. So later I need your help to implement, to edit the code and modify the code like this. And later we know that we just made a new class called keyboard input manager, and this class is derived from input manager. And let's add a new boolean flag, which is called jump over here. And just like I said before, we have to implement all the abstract methods in the parent class. So we have to implement calculate jump. This was an abstract class in parent. So whenever we implement an abstract method, we have to use the keyword override. So protected override, the return value is void, the method name is calculate jump. So in the body of the calculate jump, we try to detect whether the space key is pressed or not. And you may see that I just use get key down to detect the status of space key. That means only when the space key is pressed in a sudden and the impression would return true. And we are going to save the return value to jump. Otherwise, the return value will be false. So only the rising edge of the signal will trigger, will return a true, and we're going to save the true into jump. And then we are going to constantly invoke the event jump in uh, according to some period. Actually, it should be 60 times in a second. Okay, so that's it. All right, so after that, we are going to bind the subscriber master onto the event center, and you may use space key, right? You may use space key to jump. And I have to address the one very important thing which is not shown on the PowerPoint slide. That is, do you know that on your keyboard, have you ever tried to enable three keys in the same time? Have you ever tried to press Control Shift or A at the same time? Or Control Shift S at the same time when you're going to save some file in your office? Control Shift and S means the hotkey for save, right? So do you know that not all the combination of the any of the three key on your keyboard is valid? You may try to instantly press, for example, T and Y and U on your keyboard, and you will find that it's not possible. It will not respond. It will not respond to you, and nothing will be shown on screen. Why? That is because for your manufacturer of your keyboard, in order to let the combination of three keys to be valid, some dedicated circuits should be made. Some dedicated wires should be implemented, and that is costly. They have to buy some gold and to make the connection between the keys. So for your manufacturer, they won't make any combination of three keys to be valid on your keyboard. The more expensive your keyboard is, the more combination it supports. This is a common trend, but not always so. So later you'll see that somebody will not be able to use space key to jump. If you encounter this kind of bug, the first thing is to try to bind the jump behavior to another key. Okay, please do aware of this, okay? And later we are going to implement the wrong feature. So that means probably you are going to hold your control key and press the W key and jump key space at the same time. Somebody will see that, oh, it's not possible for me. And I think that is a bug from my code. Where is it? And after you examine thousand times of your code, you still can't figure it out where's the problem. And I'm going to tell you that the problem is not in your code. The problem is in your manufacturer of your keyboard. They didn't make all the three combination valid. So this is a trivial knowledge. Okay, but without knowing this trivial knowledge, it will bother you maybe for 24 hours. Okay. All right. Mm-hmm. So let's take 5 minutes to implement the code from page 45 to page 47. Oh, by the way, sorry, sorry. Hello, hello, 1 2 1 2. Hello, hello.
蓝牙已准备好，正在等待配对。
Okay, I forget to mention about the name of each of the key. Uh, where is it? Okay, please look at here. Just a moment, please. If you want to bind the jump key to other key on your keyboard, so here is a list. Just search C# list of string name or input key name. You see that scroll down, scroll down, scroll down, scroll down, and there is a full list of each of the key on your keyboard. You can bind any key you like to be a jump key. The most special thing among the list is that you'll never find an enter key. That is that is because that hey, look at here. Okay, the enter key in C# is called a return key. So whenever you're going to bind the jump to your enter key, you should use the name of return instead. Okay, that is the old name of enter key. 30 years ago, it was called the return key. Okay. All right. About the link, how can I share the link? This is a HTTPS. Mm, all right, I'm going to post on our MS Teams. Okay, C sharp paste or key string. After you finish the code, don't forget to bind your subscriber onto the event center. Okay, whenever you finish the jump design, you can try and see whether you have this kind of a bug. Try to jump onto the wall. Let's see, jump. And you'll find that whenever you constantly pressing the forward direction key, you will be stick onto the wall. Unless you release all the direction key, otherwise you will be stick onto the wall. What happened? That is because your movement constantly casts some forces by your physics engine, I mean the rigid body, and with that force you'll be able to be stick onto the wall. This is a little bit weird, but I can do wall jump right now. Okay. Suddenly I have a new feature, wall jump. You guys know wall jump? Okay. So we have a rocky mechanism, we have a wall jump mechanism without writing any code. Okay, interesting. Right, bye bye. Oh, actually, this is not what not I want. So how to eliminate the sticking effect? Okay, let's go back to the PowerPoint slide. This is the last section of this chapter, the last section, friction. Okay, we have shown before, without making any change to the default setting, the friction forces are not a zero nor the maximum. It's a medium value between 0 and 1. So obviously, for this wall things, I mean the cube over here, this is my wall, right? I don't need any friction force on the surface of this wall. Actually, I hope the wall acts as a polished, a purely smooth surfaces, so that whenever I'm hitting the wall, and it will make me slide down without any sticking effect. So the solution is really simple. See, we are going to make a no friction material, physics material, and set the friction to 0, and set the friction combine policy to minimum, and then apply the no friction material onto the wall. I mean the cube over here. Okay, let's have a try. We should add the no friction material before, but please make sure the value is modified like what I shown on the PowerPoint slide. Okay, after that we are going to apply the services material onto the wall. And now let's jump onto the wall again. Woo! Yay! So this time I will never be able to do the wall jump. I will never be stick on the wall. So this pretty good solve my problem. Okay, I think that's everything. Oh, you have problem with me. Right, so let's take about 5 minutes to wrap everything, and later we're going to move on to next chapter. Okay. So before that, uh, if you have any problem, please.
蓝牙已准备好，正在等待配对。
Okay, we just have a excellent question. Almost every learner, basic learner of Unity, will have some confusion about these settings. Okay, so we have an event center over here, and did you see that whenever I bind my subscriber method onto the event center, there isn't any options over here. Do you see that? But this is weird, Mr. Fu, because I know that for the move method, it should be able to pass a vector 3. And the same thing happened to the jump method. For the jump method, it should be able to pass a boolean. Where is it? Okay, so if you drop down, open the drop down over here, and select the player controller, actually you have two. You have two method with the same name. Uh, Not this one because okay, for example, the jump. So select here and select the player controller. Did you see that? I have two jump over here. One is marked as jump, very simple, and the other is marked as jump and with a boolean as its parameter. Oh, so did you see the differences? Yeah, for this one, if you select this one, sorry, it just something happened. Uh, Sorry. Okay. Now, if you select the parameters version, you'll be able to have parameters as a box over here because the parameter is a boolean, right? So you can either check the boolean box or uncheck the boolean box like this. That means you will ignore the passed argument and enforce the argument to be true or false and pass it to the subscriber. Oh, that is not what that is not I want because I want the code. So here, right? Uh, did I modify the code? Oh, okay, never mind. It's the duty of input manager to trigger, to cast, to invoke the event, right? And whenever my manager invokes the event, my manager also pass the correct argument to it, to the subscriber. But if you select the wrong version, then the settings on your editor will override what have passed from the code. I mean the input manager. This is not I want. So in order to choose the correct version, you should always look the dynamic bool version. Okay, there is a group called the dynamic something something. And on the other hand, there is another group called the static parameters something something. So if you like your code to preserve the arguments and let the subscriber to receive your arguments, you should select the dynamic version of your subscriber. So for me, I select jump. Okay. So this is very important. Okay. Oh,
蓝牙已准备好，正在等待配对。
Okay, I think we can wrap up the things from this chapter. And before we exit the chapter, before we leave the chapter, I would like to show some possible further improvements. That could be either implement by yourself, or if you want to implement or fix the problem, you can ask me how. Let's see how many things we can have some implements throughout the code. The first thing is to lack horizontal movement while jumping. Right now, when you are flying, jumping into the air, you can rotate your direction and you'll be able to turn around like Air Jordan, like an NBA dunker, doing some marvelous trick or moves. That is not possible for a human being. So I would like to regulate the moving direction when I'm floating in the air. What I'm meaning is that when I'm jumping, right? When I'm jumping, I can turn back. That is not realistic unless I'm going to make some irrealistic game. Otherwise, this is not supposed to do like this. So how to regulate the moving direction after you jumping into the air? How to do that? Right now, we don't have any finite machine, but if we do, we can regulate the direction just within the jump state, right? Once we are within jump state, then everything, the only logic that will be executed by the code is the code written in jump state. Other codes in other state won't be executed because they belong to other state. That really could solve the problem. I'm going to use finite machine to implement the feature like this. Okay, so number one, we need finite machine. Okay, and let's see the second possible improvement. Add more states like running. Yes, now we just working in a very slow speed. I would like to run if I can. And the falling, right now we have falling, but without the correct animation when I'm falling. I should have to I should have to apply some falling animation in order to have a better feeling about the control of the character. So we need a falling animation. And the heat state. Whenever there are some monsters or I just burned by some fire, I should acting like oh I'm hit. Okay, so we need a hit state. And that state, if we have an HP, I mean health point mechanism, whenever we're running out of HP, we should enter the dead state. And the roll state. A roll state is a very special state. If you have any experience on ARPG, and when you're walking, you can press some key to roll. And whenever you're rolling, uh, you'll never get harmed by any other enemies. So you are um you you're immortal. I can say that you are immortal when you're rolling. All right, and defense. Whenever you have a shield, you should be able to press or hold some keys to hold on your shield to acting as the defense states. So we need so many states. We need the finite state machine to do that. Without without finite state machine, your character will always twitching. Okay. So the following paragraph shows the same thing. Right. So next, the more characters that you design, the more robust the character controller will be. Yes, typically it is. But someday later you'll see that maybe you'll have too many states in your finite state machine. That is also a problem. And we're going to see a very interesting example in next chapter. That is from an indie game called Firewatcher. So on some GDC event, sorry, the Unity United event, the designer of Firewatcher present the finance machine they have. That is really interesting. You'll see later. Okay, next one. The character controller plays the most important role in a first-person or third-person game design. Yes. If you are going to design a first-person or a third-person game, most of the user experience will be dependent to your character controller. So, besides a third-person game, probably next time you're going to make a VR game. So in VR game, you're trying to make everything like a first person. So your experience on designing a first person game could be implemented, could be transferred into your VR design ability. So that is a dependency. That's why I'm going to say so many things about how to design a first person game, because that will be a help for your VR game design. Mhm. Okay, that's it. For some designers, they will spend several weeks to design their character controller and to make it like, do you know the Black Monkey, the new game? So even if you didn't buy the game, you can see the YouTuber playing the game. The character, the protagonist has so many interesting movements. So for each of the movement, they rely on the finance machine to work properly. Otherwise, the character, the Monkey King, he will twitch. Mhm. So that's the possible for the improvement for the character controller. Okay. All right, now let's move on to the next chapter, chapter number 7. Okay, so in chapter number 7, we are going to refactor our code. We are going to use a finite state machine to refactor whatever we have written so far. So that will be very interesting. But this is the first time you implement finite state machine into your character controller. I promise that that will be so interesting and helpful. So in the future, whenever you are trying to design a character, always remember next time, write the finite state machine first. Finite machine first the policy for your character design policies, right? So the first part of this chapter is to make a FSM to cover with your animator. So there is a huge problem. Just like I say, this is one of the designer from the game Firewatcher, and let's take a look at the interesting clip over here. Sorry, I how to connect to the amplifier. Wait a moment, please. Okay, almost there. Nothing happened. No. Oh. Hmm.
蓝牙已断开。
Hmm. Oh.
蓝牙已配对。
Okay. Okay. Wait.
Spoke model, it uses all of the same parameters that we'd already established. I actually found.
Okay, so right now let's see the share from the designer of the very famous indie game, Firewatcher. And this part, the designer is showing his animator design. So just like we use in our Unity editor, that is the animator, right? So let's take a look on how he designed the very complex version of his animator.
When I was making this presentation, I never saw it before a couple of weeks ago, and I couldn't be happier about that. It's the hub and spoke model. It uses all of the same parameters that we'd already established. It uses the same patterns that we'd already established, and our animator was able to add an entirely new layer completely by himself to make new gameplay systems have to work correctly without a programmer. That's the dream of mechanics. That's why you have a visual scripting system, so that people other than programmers can make complicated systems. This was for body blend, use both hands, hub and spoke, nothing complicated. Generic use, also nothing complicated. Hub and spoke, just as simple as the last layer. Okay, I lied. This is actually what's inside that substate machine. It goes on for a while here.
Do you see that? Do you see that? That is incredible. Do you
Hub
see
and
that?
spoke, nothing complicated. Generic use, also nothing complicated. Hub and spoke, just as simple as the last layer. Okay, I lied. This is actually what's inside that substate machine. It goes on for a while here.
So why are there so many stages? You see that? And that is because Firewatcher as an adventure game, they have many items. To interact with the item, the character needs to do different moves. A cattle, a box, or some luggage. So for different items, they need some different animation to interact with. So I remember they have 46 or similar quantity of the items. For 46 animation, and you have to correctly find the status with the animation. So this And if you want your game to be acting like more vivid or naturally in your pose, in your animation, you will have the same problem. You have the same problem and you have to face it. So that's a big problem. If we wire the status with some complex condition, because you have 46 flags. Do you remember the idea of flag? We just use the is-run or is-jump flag to mark as a condition to distinguish whether we should move on to the next condition or not. And if you have 40 to 60 flags, how many are the possible combinations? That is a power of two. That is tremendous. It's not possible to implement. So by simply using flag is not the things we are going to do because the combination of flags equals to number of the power of two. That is the tremendous state we are going to face. We're going to deal with. So we're not going to use flag anymore. We're going to use state to regulate the number of state. You can make us about 40 to 50 states or even less states to uh, to um, to package all these animations into several and limited states. So that is what we are going to do. Okay, if you have time, you are encouraged to read through all the video, and it's very very interesting. And if you are interested in making an indie game, probably you can look for the GDC videos on YouTube. Okay, let's go back to the PowerPoint slide. Okay, what is the problem this structure solved? What is the problem the crazy structure solved? It solved the needs to bridge to match the animation and the condition. Okay, it really did a good job. But some problem arises from the structure. That is the complexity, because you have to whenever you are holding a kettle, you'll be able to light the lamp at the same time, but you are not allowed to open the door at the same time. So this crossover will bridge will cast a more complicated situation on your design. So not only the game designer facing this kind of problem, but also the do you know motion capture? The motion capture industry also facing similar problem. So there is a very famous Rococo company who provides a motion capture solution, and they also put so much emphasis on this problem. So how to so I'm not able to scroll down. Mm, all right. So if you see the blog link below, you'll see that uh, their animator is really, really complex. But since they are a mocap company, they have to deal with this kind of complex animator. Okay, so that's a that's a problem. Boom. And typically, we are going to facing a problem like this. We write a C# code, right? We write a C# code, and we hope to use finite machine in this C# code. But unfortunately, Unity provides an animator for you, which is also a finite state machine. That means we have two finite machines. And if we want to sync each of the states one to one, idle state to idle animation, a working state to working animation, a something state to something animation, you have 46 while matches. And it's not guaranteed to synchronize between the state of the C# and the state of animator. Why? Because the animator has a soft transition between the states, but your C# code has a hard transition between the states. That's the problem arises. Again, your C# code, just like what we written as a switch or as a design pattern, whenever we transit between the state, it happens immediately. We call this kind of transition a hard transition, very hard. It just transition in a glance. But for the Unity animator, whenever you transit from one state to another, it could be a softer transition. It could take a non-zero time, a non-zero duration for your transition. So this kind of soft transition is not naturally matched to the hard transition, and you have to synchronize them together. That is a huge problem. So if you are following the tutorial from internet, hey, hi guys, the most important thing is this. If you following some tutorial from internet, they are always utilizing the Unity animator as the only finite state machine. So that means you can't write any C# finite machine. Otherwise, you are facing the synchronized problem. So if you learn everything from internet, you only use one animator finite machine, and you read the state from the finite machine and to see whether it matches your condition and take your responses. And this is it. And the basic usage is to use a C# stateless logic with an animator with finite state machine. This is what you follow the internet tutorial. The architecture will be like this. And is there any problem for this configuration, Mr. Fu? Yes, this configuration is easily to get character twitch or malfunction, and it's very hard to debug because you are using the soft transition animator, and you'll never get the you always get a twitching character. That is my experience. So how to solve the problem? You can change your configuration. For example, we can use two finite machine. Oh, the situation getting worse and worse. So if we do the things like this is the super hard design to debug because one is a hard transition, the other is soft transition. I personally doesn't recommend to use this kind of configuration. So let's make a workaround. Let's use our C# code and make our finance machine hard transition finance state machine over there. But we are not going to use the finance machine in animator. We'll only use the transition list animator throughout the tutorial later. So that's why our decision, that's why I'll choose this configuration from now on. Okay. Uh, let's see the quotes over here. Even if you design a bug-free animator, you still need to adequately sync it with your character interaction logic. All right, so by following the internet tutorial, you'll see that for sometimes it works properly, but whenever you are adding more states, oh, the problem arises and getting worse every day. All right, I hope you can understand why we are going to do so and what will happen if you following the tutorial from the internet. So the next topic is what is transition list animator? Well, it will be look like this. Transition is the white arrow, right? So from now on, in our animator, we'll never wire any white arrows. We're never going to make any arrow in our animator. Never. Okay, that's it. No need to wire any transition. We are going to use code to transit from one state to another state from now on. Phew, that's it. Okay. All right, so let's use a simple switch finance machine. Can you see the code? Probably not. So let's zoom in a little bit. Let's make everything from ground zero. Let's remake the whole player controller. So in the beginning, we are going to declare a state. Oh, wait a minute. Sorry. Now we should have a 10 minutes coffee break, right? All right, let's have a rest first. And because we have, we need everybody to put a little bit attention to the code since this is the repetitive version. Well, let's have a 10 minutes coffee break. Mm.
蓝牙已准备好，正在等待配对。蓝牙已配对。
Okay, welcome back. So let me introduce the switch type FSM that we are going to implement. So let me zoom in a little bit. All right, that's it. So for the new player controller, we are going to override everything. Override everything. Of course, you can rename your old controller to other name or just delete everything. I suggest you delete everything because we don't need to keep the original code. We are going to make a turbo version of our player controller. So in the beginning, we declare an enumeration which having idle, walk, and jump. These are the three first group we are going to implement in the first version of our FSM. And later we're going to instantiate. We're going to declare an enumeration having the same name as the state, but with all letters written in small letters. State. And then this is the same with the previous version. We declare a float number, velocity, and float number, jump thrust. And we take a reference to the model. And then we declare a vector 3 of moving vector, and the animator thing, and the rigid body thing. And we just keep the flag design of thrust. This is for simplicity. So we just keep the flag is thrust over here. And we need another flag, which is trigger enter, because now we are implementing the switch type FSM. Okay, so in the awake, we having the same configuration to the previous version. We just get the component of animator and the rigid body over here. And in line number 27, we initialize our state to the idle state. Okay. And later, in the update method body, we see from line number 32 that we initialize the new velocity to be a zero vector. This is zero vector. And after that, we are going to do the same thing as before. We calculate the horizontal component of moving vector. And on the other hand, we calculate the vertical component too. And we just compare the horizontal component and vertical component to see whether the right component or the forward component should be applied onto the moving vector. Okay, next. All right, now we see our huge switch over here. Is that huge? Is that huge enough for you? Somebody may think, oh, this is a little switch. I can take that. I can bear with it. All right, now we just have 3 states. If you implement 30 states, there will never be the same thing. You will have a very long switch. Okay. So right now, okay, we are just making everything simple, and I can bear with it. All right, the huge switch is over here. So we see that from line number 46 to line number 58, this is for the idle state. As usual, we will put the unentered things in this part. Okay, so in the unenter of the idle, we are trying to crossfade the animation into the idle animation. So this is the first time you see this API, right? This API is called crossfade in fixed time. Originally, we were using play to play a new animation, but this time, obviously, we use a different method, different API, and the name of the API is crossfade in fixed time. That means we are trying to make a soft transition for animation. But the logic is still hard transition because the logic is controlled by my C# code, and I use a switch to control the logic state. So for animation, I doesn't care the accuracy. You can take, for example, a 0.1 second to finish the transition. I don't mind. Okay, it's just for beauty. Okay, so let's do the transition like this. And after that, I finish everything I need in onEnter. So I just set the trigger enter flag to false. And you see that I put a break over here. So I will leave the switch whenever I execute the break over here. That means that I will totally exit from the switch, and after 1/60 seconds, and go back from the start, and then I will execute the other part of the idle. Okay, let's see what's going on in the other part of idle. So this would be taken as a is state logic. So the first thing is to distinguish whether now there are any intention from the player to move the character. So we detect the moving vector, we detect its magnitude. If it's greater than 0.1, then we think that my player is trying to do something. If this is the case, we are going to another state. We are going to transit to the work state. Mhm. Otherwise, otherwise we are going to stay in idle state, and we are going to set the new velocity to 0. Okay, that's everything for idle. Now for the walk state, I think the architecture is pretty similar to idle, and you can uh, very soon get the idea of the walk state. So in the onEnter of walk state, we're going to transit our animation into walk. We're going to use 0.1 second to finish the transition. This is a soft transition. And after that, we finish everything in onEnter. We just set the trigger enter to false and break the switch. Okay, so whenever we enter the walk state twice, we're going to compare the moving vector to see whether its magnitude is less than 0.1. If this happens, and we think that the player's intention is to stay at stay at here, no, so we go back to the idle state. Otherwise, we're going to save the new velocity with a value of descend to a moving vector times velocity, and we are going to rotate our model a little bit with the help of spherical loop, we just introduced before. Okay, so that is everything we do for the walk state. And finally, we see the final part of the switch is for jump state. Oh, this is the third time I see the same structure. You see that? For every state, we always write the onEnter logic in the beginning, and we have to detect whether trigger enter is set or not. If trigger enter is set, that means this is the first time we enter this state. Then we are going to make the animation, update the animation to what we want. For jump state, we need the animation to be jump. So you see jump over here. So we give it 0.1 second to finish the soft transition. So this is the why you see the code over here. And after that, we just set the trigger enter to false. And don't forget that we need to assign the new velocity to the current rigid body velocity. Okay, this should be the same thing to the last version, what we written last chapter. Okay, so for the rest part of the jump state, we are going to override the new velocity as usual and leave the switch. Okay, this is at the end of the switch. Oh, huge switch. If you need a documentation for the crossfade fixed time, you can click the link over here. Okay, next. Okay, I'm going to finish this part very soon, and let's finish the code. After we exit the switch, we're going to update the velocity. So this is the code, the stand to what we had wrote before. And then we're going to implement the goTo state for the goTo state. And in the goTo state method, we're going to write the state value to the new target state. And we're going to set the trigger enter to true. because whenever we transit to another new state, we should execute the unenter method of the new state. And later we see the move. This is the send to the last version. And this is jump. Oh, there are a little bit tweak in the jump method. We see that whenever we found that the if thrust is true, that means our player is just pressing the jump button. And we are going to do a further detection. If right now the character is in idle or in walk, then we allow it to jump. Otherwise, if the player is already in jump state, then the signal will be omitted. Please try to make the new state diagram by yourself, but I'm going to uh, make you an example. Just like we said before you start to coding an FSM, you should finish the FSM diagram. But this time, obviously, we didn't do that. That's my bad, my fault. Sorry, because I can write such a diagram in my mind. All right. Let me show everybody the FSM we are making right now. We have three states: idle and walk and jump. Okay, idle can transit to walk, walk can transit back to jump, and idle can transit to jump, and walk can transit to jump. And what if the jump is finished? What if the jump is finished? So can you get at the question? Is this now everybody look at the diagram over here. Is this complete for you? Is this state machine a simple character controller with three states? Is it complete for you? Or is there anything missing right now? Idle, walk, and jump. Obviously, no matter which way you enter the jump, you will never leave the jump state. Can you? Can you leave the jump state? No, there isn't any arrow. Okay, so you will be locked in jump state. That is the bug. So what is the condition to leave jump state? Jump and and uh, and 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 yeah, you are touching the ground, right? So whenever you're touching the ground, you should leave the jump state. And what is the next state? All right. So actually, whenever you are touching the ground, you can either go back to idle or you can either go back to walk. But no matter any one you choose, you may be able to transit to another one in a very short time. Because whenever you trans back to idle, but you are having some intentional moving pattern other than zero, then you will very fast, very soon transit by this arrow, right? So I decide to implement the transition from jump to idle like this. Now this is complete. Now this is complete. Okay, so let's finish the red line over here. We just finished the idle to walk and walk to idle. Now in the code part, in this part, from line number 107 to 108, sorry, 104 over here. So that means when you are detecting somebody is pressing the jump, and whether you are in idle or you're in walk are allowed to jump. So in this situation, we just set the instruct true and go to state jump. Finish. I just finished it. Check it. All right, so I didn't finish this part. So let's go back. Let's see the line number 117 over here. This is on collision enter. So who will trigger this on collision enter? The owner of this script should have a rigid body. If this is the case, the rigid body will trigger the on collision enter for you because the rigid body will trigger the functions belong to the brotherhood level, the sibling level, you know the sibling level. So the animator, sorry, the rigid body will see, oh, who carries the on collision enter, who are my siblings? Oh, you carry this kind of API. Okay, I'm going to invoke the method for you. The rigid body will invoke the method for you whenever it collides with somebody else. So this is the case our character is touching something, not not much the ground. I just know that it touched something. And if it touched something, I'm going to transit the state to idle. Okay, that's it. All right. So that's the final, the new version, not the final version. That is the new version. You can jump, and this time you are not allowed to um sorry uh this time you are not allowed to turn over when you are flying in the air. You can try by yourself because uh you didn't make any direction change when you are in jump state. In the previous goal, we use line number set 71 to implement the only direction moving, right? But we didn't implement this line in jump state. So in jump state, you are not allowed to move to other direction. All right, so take 10 minutes to finish the code, okay? We're going to use 10 minutes to finish the code from 6 to 8. Mm, Okay. Let's have a discussion later. Yeah.
蓝牙已准备好，正在等待配对。蓝牙已配对。
Okay, hi. So I hope you finished typing the code and let me show the result of the new version. So this time, whenever whenever we are jumping in the air, we are not allowed to move our direction. But if we intentionally to jump onto the wall, that some bug still arises. You can see that whenever I touch the wall, I'll be able to rotate freely. That is because whenever I touch the wall, I go back to the idle state. You can see that we have a state variable, right? So right now, walk, idle, walk, idle, walk, idle. You can see the state over here. You can check the state over here. And whenever you bump into the wall, you'll go back to idle. You'll leave the jump status. So one workaround or a quick fix is to mark the wall as a different tag, or to mark the ground as a specialized tag called ground. So if you have some reference game, you can download some reference game or buy some reference code from the internet, and half of them will mark movable ground as a ground tag. And the ground tag has another benefit. If you are going to use a Unity navigation solution for your enemy need to use the Unity navigation AI. So you need to bake all the ground in order to let the Unity navigator to know whether you can walk through, whether the enemy can walk onto it. So most of the time, you'll be adding a tag called ground and mark all the ground things as ground tag. So if you mark all the ground, you can distinguish wall from ground. So next time in your collision enter, you can check the tag first. You can check the tag over here, here. If the tag having the tag of ground, then we're going to transit to idle. But this is an advanced feature. We are not going to do it right now. So let's talk about one more, the fourth state. And let me see. Probably uh, probably not today. Okay. All right. So last time we were talking about um yeah, last week I have some business to do, so I just go to the ceremony and join the lecture of Adam Back. So I'm going to record the following sections and post it onto YouTube, so you can learn. Sorry. Okay, 这样子. So you can learn by yourself by watching the video at your paces. Okay. All right, so before the end of this lesson, I'm going to introduce the fourth state. From now, from now on, we will repeat the same thing for several states, including the flow state, the roll state, the locomotion state. You will follow exactly the same procedure to add more state. So in the common procedure, the first thing is to find an animation and drag into your animator. Animation is very important. It directly take effect to your user experience. So this time I prepare a following animation for everybody. You can find the animation file over here, the whiteboard, the extra folder. You'll find a whiteboard at the following idle. Okay, you will be look like this, like gliding in the air. Very cool. So after you add an animation to your animator, you'll be able to crossfade into the states. Oh, okay. In the first glance, you'll find the code is pretty complex, but actually it's really simple. Let's take a look by following the older notation over here. The first part is adding a state. Since we are adding a false state, we give it a name FALL in capital letters. And then later we're going to read the animator state from animator. So in order to read the state from animator, we have to declare a temporary variable which having a type of animator state info. And later we're going to read the state of the animator back to this variable. Okay, now we are going to tweak the jump. So in the jump logic, as you can see that in line number 87, we just read the state back to the state info. And later we're going to distinguish whether now the animator is playing the jump, is playing the, whether now we are playing the jump animation, and whether the process of the jump animation is surpassing the 80%. So if now we are playing jump and we already passed the 80% of the animation clip, then we'll decide to transit to full state. That means you are right now falling because the animation is closing to end. All right. And later we're going to write the logic for fall, just like you can see that. In order to implement a new state, the first thing is to crossfade into the animation. So we just crossfade into the false state. And then we're going to recover the trigger enter boolean back to false. And then we are going to lock the velocity into the current velocity. So we just copy the rigid velocity back to the new velocity. And we just exit on enter part. And for the rest of the false state, we just copy the velocity from rigid body to the new velocity. That's it. That's it. Simple, right? And the collision part, we just made this so we don't need to re-implement this part. And the problem is that when to trigger the false state. All right, my bad. I should draw the sketch before implementing the code. Let's have a discussion. We use less than 3 minutes to finish the part. Okay, now I have a fall. So, where should I put the transition from some state to fall? Obviously, only the jump. The fall state would only be following the jump state. And if the jump animation is finished, actually approaching the 80% of the clip, then we are going to transit to the full state and taking the 20% of the rest of time for the soft transition. And what is the this is not complete, right? So what is the condition to exit full state? And what is the next state when we exit full state? George, do you have the answer? Say it. What's the condition? What's the condition? Touching, right? And what is the next state? And idle? Yeah. Idle maybe. Okay, great. Yeah, you get me, but you get me, buddy. So I'm going to put a transition from fall to idle, and we know that the condition is when you're touching ground, or or when the oh yeah, that's it. Okay, so you can see that jump in this. Now we're going to implement the jump to fall transition. We see that we can detect whether the jump is surpassing the 80% or we can use an animation event to do so. So do you know animation event? We can mark some annotation on your animation. So when the animation is play, 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 and when you see, and when it sees the animation event over here, it will try to call another method which belongs to the sibling layer of the animator. But today I'm not able to introduce the detail because we don't have too much time. So I'm going to introduce the detail and next week. All right. And that's it. When you finish the code like this, you'll be able to jump and fall, jump and fall. This is using the method one, which is by reading the status info back and try to distinguish whether the process is surpassing the 80% of the clip. And this is method two by using the animation events. Mhm. Both of the methods should work properly. As you can see, after the jump animation is finished, and you're going to play the gliding falling animation. But sometimes it works improperly. This is a bug. When you successively pressing the jump button, it will you'll see some bug from the finance machine. Why? Okay, this is a question for you. Okay, why? Why I successfully press the jump button very rapidly and I'll see the bug? Why? Think about it. Right. So we're running out of time. So today we are going to stop at here, and if you have any problem, you are welcome to contact with me, and I'm going to have a very well discussion with anybody having any problem. Okay. So any question? All right. So let's call it a day. Thank you for your attendance, and see you next week. Okay, and next week we're going to enter the December, right? And I'm going to uh, officially announce the final project requirement, and that will uh, then you will have about 1 month or less than 1 month to have a well prepared about the final project. The final project is an ARPG or anything with a character controller. I want the character controller to be implemented in your final project. No matter you are following my method or you just following the internet tutorial, either way will be acceptable. But if you can learn something from the series, I think you'll learn a lot of things that is not shown on any internet tutorial. Okay, I have confidence the structure I showed throughout the series of this lesson you'll never find this kind of structure on internet, right? Because it's I personally making this character controller like this. All right, okay, see you next time. Okay, bye bye. Okay, I think because Professor Long will having a lecture over here, then he invites professional lecture. We have to clean the table and pour all the